A voltmeter is used to measure a potential voltage difference across 2 points in a circuit. To measure voltage in a circuit, the meter is connected in parallel with the components to be measured. To accurately measure voltage, it's important that the meter have a negligible impact on the circuit being measured. Therefore, voltmeters have a high internal resistance to prevent current from flowing through the meter. Connecting them to a component, therefore, will not affect the voltage being measured. If the voltmeter's internal resistance is less than 20 times the component's resistance, current will flow out of the circuit into the meter, resulting in an inaccurate voltage reading. Ammeters are used to measure current in a circuit. They are connected in series with the components to be measured. This means that the ammeter is placed in line with the circuit to be measured. Ammeters have a low internal resistance, so that connecting them in series with the component should not change the resistance of the circuit and therefore not affect the current being measured. Never connect an ammeter in parallel with a component. Because of the very low resistance of the ammeter, the current from the circuit will bypass the resistor and move through the meter. If the current level is high and there are no other current limiting components in the circuit, the high current flow can damage the meter. To measure resistance of a circuit component, an ohm meter is used. Like a voltmeter, an ohm meter is connected in parallel with the component to be measured. Ohm meters are never to be used in a powered circuit. It can damage the meter as well as present a safety hazard. So make sure switches are open before applying the leads of an ohm meter to a circuit. To measure resistance, an ohm meter has an internal voltage source which generates a small current that flows through the component being measured. The meter will automatically perform an Ohm's law calculation by dividing the voltage it applies by the current flowing, resulting in the resistance value. Today, all-in-one digital multimeters like this can be used as a voltmeter, ohm meter, or ammeter. They offer faster and more accurate readings.
A multimeter. It lets us measure both voltage and current over a wide range of values. It's called a multimeter because it combines many instruments in one. We can also use it to measure resistance and AC voltage, amongst other things. Now, to use it to measure voltage, I'm first going to plug in the leads. The black lead always goes in the black socket marked common. To measure voltage, I'll plug the red lead in here where it's marked V. To measure an unknown voltage, I always start off on the large range. This range here says 600 volts. That's the full scale deflection. That means the largest voltage that the instrument will read on this range. Let's plug it in to this battery. You can see I get a reading, but only to one significant figure. How can I be more precise? I move down to the next range lower, marked 200 volts full scale deflection. You can see that my reading is now 1.5 volts. That's two significant figures. I can be more precise by moving to the next lower range. This range is 20 volts full scale deflection. My reading is now 1.54 volts. The next range down is marked 2000 M. That means that the full scale deflection is 2000 millivolts or 2 volts. The reading is now 1535 millivolts. The next range down is marked 200 millivolts. If I was to change down to this range, you can see that the reading is too high for it. Let's do it and see what happens. The reading has now gone and I just get a 1 on the display. This means that the voltage input is too high for that range. If this happens when you're doing an experiment, you simply need to increase the range until you get a proper reading. Into this socket marked COM for common. The leads are both just insulated copper wires, but by convention we always plug the black lead into COM. With any multimeter, you need to look at the labels on the other sockets to see which one is appropriate for what you're trying to measure. There's a fuse inside here, and if you use the wrong socket, it could blow or you could even destroy the multimeter. On this multimeter, there's just one voltage socket, this one marked V. However, if you're going to measure current, there's a choice. If you've no idea of the size of the current, then start here. This socket, on this setting, lets me measure currents up to 10 amps. But nothing smaller than 1/100th of an amp. If you go above 10 amps, you could destroy the multimeter. Let's measure the current in this circuit. Ammeters are always connected in series, so I need to break the circuit and then complete it again with the ammeter in series. The minus just means we have the opposite polarity. 0.14 amps. That's 140 milliamps. Since this is below 200 milliamps, I can measure it more precisely using one of the more sensitive ranges on the multimeter. In order to do this, I need to move the red lead into this socket marked milliamps, which is connected by a fuse which will blow if the current exceeds 200 milliamps. Let's measure the current again. 135.2 milliamps. This is on the 200 milliamp full-scale deflection range. If I move to the 20 milliamp range, the current is too high. So I get a 1 on the far left of the display. But there's no harm done. I just click to a higher range to get a reading. The fuse will only blow above 200 milliamps. If the milliamp ranges do not work at all, I just get a 0, then someone has blown the fuse and it needs to be replaced. However, the meter will still work as a voltmeter.